The connections between classes in a UML class diagram are called relationships. Examples include association, inheritance, composition, and so on. Now, inheritance and implementation, implementing interfaces, are taxonomic relationships that describes hierarchy. If B inherits from A, then B is A plus more. Taxonomic relationships are design time relationships. They are designed in code and they are permanent. Now, on the other hand, there are association, aggregation, and composition. They describe how objects relate to each other in terms of reference and ownership and life cycle. These relationships are also designed at design time, but manifest themselves at runtime through object instances. Now, the first relationship we are going to look at is dependency. Underneath of all the other relationships is the dependency relationship. Every other relationship implies dependency. When object A has a relationship with object B, object A depends on object B. Now, this is what it looks like in a UML class diagram. It is easy to spot in a module file. Now, here is main.py. Module main has a dependency on datetime. Now, since datetime is a different module file, we say that main has a source code dependency on datetime. Now, look at this main. Class employee is defined and instantiated. You are looking at two modules, the class and the rest of the code in main. Main depends on the employee module. Since they are in the same module file, there is no need to import anything. Now, what happens when class employee is moved to employee.py? Main must now import employee. Main now has a source code dependency on the employee module. Interesting. Now, there are more situations that require dependencies on employee. Here is module report.py with class report. The print employee method takes an employee and prints it. Since Python does not require static types in the code, there is no need to import employee. But even if there is no source code dependency on employee, there is still a runtime dependency at runtime on employee. You can check this. Every Python developer knows what would happen if you send wrong objects to methods. The code will likely crash at runtime. But Python supports type annotations which make these dependencies visible in the code. Once I annotate employee, I have to import the employee module and I'll use type annotations from now. Now, what you just saw are dependencies. Module A depends on module B, nothing more. The second type of relationship we're going to look at is the association. When the employee object is used in more places in the reporting module, it might be a good idea to store it in the object. The report module still depends on employee, but it does more. It stores a reference to an instance of it. Now, this is known as association, and it looks like this in the UML. Now, association does not prescribe how a report gets an employee. It only states that report has a reference to employee at runtime. Now, in 99% of my code, I would do this through dependency injection in the class initializer. Now, so far you've seen dependency and on top of that association. And here is where things get a bit confusing. When object A stores a reference to object B, UML classifies this as an association. However, developers often colloquially say that object A is composed of everything inside object A plus the things in B. In this informal usage, composition refers to the act of building an object out of multiple parts, not to UML composition, which has a stricter whole, part, and life cycle meaning. Now, the multiple meanings of composition are a frequent source of confusion in design discussions among developers, and we need to differentiate between them. When objects store references to other objects, in UML known as association, we will speak of technical composition. Now, the next step in our relation is aggregation, depicted with the open diamond. Aggregation requires a dependency and a stored reference. But if that was also the case with association, then what is the difference between them? To answer this question, let me show you 3 aggregation examples. Example 1 could be a department has employees. Another example could be a playlist has songs. And yet another example is a folder has files. Now let me give you 3 association examples. Now, a mail client has a logger, a user has a session, or a user service has a user repository. Do you notice the difference? With association, 2 objects collaborate in a technical way. A mail client uses a logger. A user service requires a user repository. But these collaborations are technical. They are probably unknown to the user of the software. Now, in contrast, aggregation describes domain relationships. For example, a department has employees or a playlist has songs. Such relationships are often visible in the UI of the application. A technical relationship with a logger is hopefully invisible to the user of the software. Now, dependency, association, aggregation, if this all starts to dazzle you, and I certainly know it did to me when I first looked into all this, you're in good hands, because what I did is I gathered all this information and put it in a nice ebook for you. Now, the link is in the description, and I recommend you download it and memorize it, because it will help you with your next discussion during design meetings. Back to the tutorial. Okay, we're almost done, I promise. So, dependency, association, aggregation, and on top of that is composition. Since we already saw there is such a thing as technical composition, I will explicitly call this UML composition. Now, just like aggregation, it describes a whole-part relationship. But with aggregation, an object does not create its own dependencies. Instead, it receives them and stores them in a reference. Now, UML composition does things differently. First, let me show you what it looks like. With UML composition, object A creates object B. This implicates that object A also is responsible for the life cycle of object B. Once A is destroyed, B will also be destroyed. A good example of this is an HTML document. To build this document in code, you need objects that act as nodes and leaves. Simply put, nodes store children and leaves store text. The root of the object tree is an object of type HTML. What happens when this object is destroyed? All child objects must also be destroyed. There is no conceptual reason for a body, heading, or paragraph to exist without an HTML container. Now, let me give you an overview of common UML relationships. There is realization, inheritance, dependency, association, aggregation, and UML composition. Now, we have focused on dependency, which is the underlying relationship of all the UML relationships, and association, aggregation, and composition, which focus on runtime behavior. There's only one more thing that I like to say, and that is about cardinality. A common pitfall during UML relationship classification is taking cardinality into account. Cardinality specifies the number of instances that one class could be related with to another class. For example, one-to-one, or one-to-many, or many-to-many. These number specifications do not affect the semantic strength of the relationship. If you made it so far in this video, let me tell you again, I put all this in an ebook and you can download it with the link in the description. I hope this helped you.